This is a revision video for my Year 11s on completing the square. Now, when we complete the square, we want to rewrite an expression in a form x plus something squared. Now, to get the something in the brackets, we always have the x coefficient. So a half of 6 is 3. Now, these two expressions are now almost equivalent. If you expand x plus 3 squared, that means x plus 3 bracket x plus 3. Then you get an x squared. 3x plus 3x is 6x, and 3 times 3 is 9. So if you compare the two expressions, the x squared term is correct, the 6x term is correct, but I've got a 9, not a 1. So to make the two things equivalent, I must take away an 8, because 9 take away 8 is 1. So if I put a take away 8 here, because 9 take away 8 is 1, the two expressions are the same, and this is called completing the square. I can use that for two main things. Number one is to solve equations that don't factorise. Now, if I've got an equation equal to 0, I can rewrite the x squared plus 6x plus 1 as x plus 3 squared minus 8 equals 0. That was a bit from the first part of the question. Then to solve this, I add 8 to the other side. It becomes positive 8. There's a square there, so I now square root both sides. If I square out the square, it cancels off. So I'm left with x plus 3. I therefore have to square root the 8, which is a third. But there are actually two answers here. There's the positive square root or the negative square root. Therefore, to find x, I then take away 3 from both sides. So x is equal to either the positive or negative square root of 8 minus 3. And these are the two solutions which I could then work out, if required, on a calculator. So to review that, we'll look at a second question. The same method, but this time there is a minus 8 rather than a plus 6. So the method was, again, we always have the x coefficient. So I get an x, but in this case I get a minus 4 squared. But again, if I were to expand x minus 4, I get an x squared, a minus 8x, so the first two terms are correct. But minus 4 times minus 4 is plus 16. There's an 11 here. So to make the two things equivalent or the same, I must take away a 5, because 16 take away 5 is 11. So I've completed the square. Then to solve the equation, I rewrite it as x minus 4 squared minus 5 equals 0. I then add the 5 to the other side. I then find the square root to cancel off the square. So x minus 4 equals root of 5. But there are two solutions, the plus or the minus solution. So to finish off, x equals plus or minus root of 5, and then I've got to add the 4 to the other side. And they are the two solutions to the equation. Now, in the third example, I then use that method to sketch a graph. So I have the 8 to get a 4. To be quick now, 4 squared is 16. I need a 5. 16 take away 11 is 5, so I take away 11 like so. Now, this gives me a very easy way to sketch the graph. Now, an x squared graph is a quadratic, it's a U shape. And this U is somewhere on the graph. But within this, there are some key points. Now then, the plus number or negative number at the end is always the y-intercept. So this graph must go through +5 on the y-axis. So a U either comes down like this or down like this. But there's a trick to work out where the vertex or the bottom of the graph is. And it comes from the x plus 4 squared minus 11. Now the quick method to work it out is we swap the sign in the bracket to get, in this case, -4, and we keep this sign. So we keep it as minus 11. And this is actually the coordinate of the bottom of the graph. So if I go -4 and down 11, it's only a sketch, then that coordinate -4, -11 is actually the bottom of the graph. So it must come down to there, then back up again. So the sketch looks something like this. It's only a sketch, but this is the sketch of y equals x squared plus 8x plus 5. So in summary, the plus number at the end, in this case, is the y-intercept. And the rule is, if you can complete the square, we swap the sign in the bracket to get the first number in the coordinate, we keep to get the second number, and that is the vertex or the bottom of the graph.